Okay, get this. Even with all the hype about AI getting super smart,
Yeah.
even like GPT-4, the big kahuna, it still struggles with like really complex math problems. So, maybe it makes you feel a little bit better about struggling with algebra back in the day.
Yeah.
But speaking of which, today's deep dive, we're talking about a paper that's all about trying to figure out how to make AI better at math.
Interesting.
And by the way, if you like these deep dives, hit that subscribe button so we can keep making more of them.
Yeah, that's a great point.
So the paper we're looking at is called Accessing GPT-4-Level Mathematical Olympiad Solutions via Monte Carlo Tree Self-Refine with Llama 3.8b, a technical report.
Wow.
Yeah, it's a mouthful, I know.
Yeah.
But stick with me, okay, because it's a really cool idea,
Okay.
basically.
Yeah.
These researchers, they wanted to see if they could make AI better at solving these super, super challenging math problems.
Right.
Like, the kind that you might find at a math Olympiad or something like that.
Oh, wow. Okay.
And to do this, they combined the power of LLMs,
LMs.
which are large language models, with a special type of algorithm called Monte Carlo Tree Search.
Okay. See.
Yeah, or MCTS for
Oh,
short.
I see.
So it's kind of like they're teaming up to try to solve these problems.
A tag team. Yeah.
Exactly, a tag team.
I like that.
So imagine you're trying to solve a really, really difficult puzzle, right?
Okay.
Having an LLM is kind of like having all the pieces of the puzzle, but you have no idea how to put them together.
Right.
But then having this MCTS is like having a strategy guide that helps you, try different combinations and figure out how the pieces fit together.
Interesting.
So if you combine both of those things, it's like you have the pieces and the guide.
Yeah.
And so it makes solving the puzzle a whole lot easier.
Oh, I see. Okay.
So before we get into the details,
Yeah.
can you give us the big picture overview? Like, what's the main goal of this research, and why should we care about this?
Yeah. Well, the researchers really wanted to see if this combo of LLMs and MCTS could actually help AI solve those really, really hard math problems.
Right.
Like the ones that even make, really smart people scratch their heads.
Yeah.
And the reason why this matters is because, well, think about it. If this works, it could be huge for education.
Right.
Like, imagine AI tutors that are actually able to, adapt to a student's individual needs or help them work through those really tough math concepts that trip them up.
So we're talking personalized learning, really fine-tuned.
Yeah, exactly. That's the idea.
Wow. Okay, now you've got me hooked. So how did they actually test this out? Like, what was their process?
Okay, so they tested this new method, which they call MCT Self-Refine, or MCTSR for short.
MCTSR.
Okay. And they tested it on a whole bunch of different math problems. And these problems, they range from, basic grade school math all the way up to, the super tough Olympiad-level problems.
Oh, wow.
Yeah, so they really put it through the ringer.
So they weren't messing around.
Not at all.
They really wanted to see
Yeah.
how this thing could perform.
Exactly.
Okay, cool.
And they used several different sets of math problems, each with its own kind of quirks and challenges.
Oh, interesting.
Yeah.
Yeah.
Just to see how well MCTSR performed compared to just using LLMs on their own.
Oh, so it's like a head-to-head competition.
Yeah, kind of like that.
Okay, awesome.
Yeah.
I'm all ears.
Good.
What did they find? Like, did this dynamic duo, did it live up to the hype?
Well, let's just say you'll be amazed to see how MCTSR tackles these problems from, like I said, grade school to Olympiad level.
Okay.
And there's definitely a pattern. The tougher the problem, the more MCTSR shines.
Oh, interesting.
Yeah, it's pretty cool.
So it's not just a one-trick pony. It can handle the easy stuff, but then
Wow.
when it gets really hard,
Yeah,
it really steps up its game.
exactly.
Okay, so give me some specifics.
Okay.
How much better did it actually do?
All right, so for the easier problems, like those in the GSM-8K dataset, think, elementary school math.
Okay.
MCTSR aced it. 96% success rate.
Wow, that's impressive.
It is, but to be fair, even the LLMs on their own, they did pretty well in that one, solving around 74% correctly.
So they both passed, but MCTSR definitely got the A+.
You got it.
Okay.
But hold on tight, because things get really interesting when we crank up the difficulty.
Okay, let's hear it.
All right, so on the GSM hard data set, think middle school, high school level problems.
Okay.
The LLM started to sweat a little bit. They only solved about 33% correctly.
Oh, okay.
But MCTSR, it kept its cool almost 46%.
Wow, that's a pretty big jump.
It is.
Just by adding that extra layer of strategy.
Yeah, that strategic search element really seems to make a difference when things get tough.
Yeah, for sure.
And that trend continued across the board. We saw similar results with the math data set, which is based on high school math competitions.
Okay.
MCTSR consistently outperformed the LLMs alone, especially as the problems got harder.
So it's like the Rocky Balboa of math problem solvers.
I love that.
It just keeps going.
Yeah, going the distance.
Even when it gets really tough.
Absolutely.
Awesome. Okay, so...
And speaking of going the distance, the researchers even tested MCTSR on Olympiad-level problems from the AIM, Math Odyssey, and Olympiad bench data sets.
Okay, now we're talking the big leagues.
Yeah, this is the major leagues.
All right, so how did it do against, like, the math Olympians, the best of the best?
Well, no AI has managed to completely conquer those data sets yet, to be honest.
Mm-hmm.
The problems are just notoriously difficult.
Right.
But MCTSR still made a respectable showing. On the AIM data set, it solved about 12% correctly.
Okay.
Which is, 6 times better than the baseline LLM.
Wow.
And on Math Odyssey, it cracked almost 50% of those uniquely challenging problems.
Wow. Okay, so not too shabby.
Not too shabby at all.
For a system that's going up against the elite.
Yeah.
Okay, so
Yeah.
MCTSR might not be winning, a Fields medal quite yet,
Not yet.
but it's showing some serious potential.
Yeah, it definitely is.
But, before we get too carried away,
Right.
let's put on our critical thinking caps for a second.
Yeah.
What are some potential issues or limitations with this research?
That's a great point. It's important to remember that this research is still pretty early.
Okay.
And one thing to keep in mind is that they only tested MCTSR with one specific LLM,
Okay.
and that's Llama 3.
Llama 3.
Yeah.
Okay.
So we need more research to see how well this works with other LLMs. It's possible that some LLMs might be better suited for this kind of approach than others.
Hold on. So relying on Llama 3, that seems a little, risky, right?
Yeah.
What if other LLMs just don't play as nicely with this MCTS here?
That's a valid point. Yeah, it's too early to tell for sure how well this will work with other LLMs, how generalizable it is.
Right.
It's possible that we might need to tweak things a little bit
Right.
to make it work with other models.
So more research needed before we declare MCTSR the ultimate champ.
Definitely.
Okay, but still these results are pretty exciting.
Yeah, they are.
So what do you think this means for the future of AI and education? Where do we go from here?
Well, if this research is any indication, I think the future is looking pretty bright.
Okay.
Imagine learning platforms that can actually adapt to each student's individual needs and learning styles.
Yeah, I remember sweating bullets over basic algebra in high school.
Yeah.
And now we have AI tackling Olympiad problems.
I know. It's incredible.
It makes you wonder if, I should have just waited for the robots to do it for me.
Maybe a bit of both.
Yeah.
But in all seriousness, this technology really does have the potential to make learning more engaging and accessible for everyone.
Right. And it could be a game changer for fields beyond education, too, right?
Yeah.
What about scientific research or engineering?
Oh, absolutely. The potential applications are huge.
Yeah.
Imagine AI helping scientists solve complex equations.
Yeah.
Or helping engineers design more efficient structures.
Right.
And it's not just about solving existing problems.
Right.
AI could actually help us uncover new mathematical insights and patterns that we might not have even thought of before.
It's like having a mathematical muse whispering in your ear.
Yeah, exactly.
Okay, this is really mind-blowing stuff.
It is.
But I'm also curious about the ethical implications.
Yay.
As AI becomes more and more sophisticated,
Yeah.
how do we make sure it's used responsibly?
Uh-huh.
How do we make sure it doesn't, perpetuate any biases that are already out there?
Yeah, that's a crucial question.
Yeah.
As we develop these powerful tools, we need to be so mindful of their potential impact on society.
Right.
We need to make sure that AI is used to promote fairness and equity, not make existing inequalities worse.
Absolutely. It's a huge responsibility.
Yeah.
Okay, so where do we go from here? What are the next steps in this research?
Well, one obvious next step is to test this method with other LLMs, as we were talking about.
Right. See if it's a one-hit wonder or if it's really got the chops.
Exactly.
Okay.
And another interesting avenue would be to explore how MCTSR could be adapted to solve problems in other domains, like you mentioned, science, engineering, maybe even art.
Oh, wow. Yeah.
It's really exciting to think about.
Yeah. The possibilities are pretty much endless.
They are.
I can't wait to see what the future holds for this kind of technology.
Me too.
Okay, so before we wrap up, could you give our listeners a few, key takeaways to ponder?
Absolutely. So first, combining LLMs with search algorithms like MCTS,
Right.
it shows a lot of promise for improving AI's problem-solving abilities, especially in, complex areas like math.
Okay, check. What else?
Second, while the results are promising, we still need more research
Okay.
to figure out how generalizable this method is and whether it can be applied to other LLMs and problem domains.
Got it. Anything else?
And finally, like with any powerful technology, we have to think carefully about the ethical implications of AI and make sure it's used responsibly and equitably.
Well said.
Yeah.
Okay, folks, so there you have it. We've delved into the fascinating world of AI math wizards, explored the potential of MCTS here, and considered the exciting possibilities and ethical challenges that lie ahead.
It's been a great discussion.
Yeah, absolutely. Stay tuned for part 2, where we'll wrap up with some final thoughts.
Sounds good. Welcome back to our deep dive into AI and complex math problem solving.
It's like we're going back to school, but way more intense.
Yeah, definitely a bit more challenging than your average algebra class.
Okay, so last time we left off, you were
Right.
telling us about how MCTS, you're this new method for helping AI solve math problems.
Yes.
It was actually performing pretty well against those super difficult problems.
Yeah, it was holding its own, especially when things got really tough.
Right.
It was kind of like, it has the secret weapon, this Monte Carlo Tree Search algorithm.
Right. It's like the brains behind the operation.
Exactly. It helps the LLM, the large language model, explore different possibilities and find the best path to a solution.
Okay, so it's not just about brute force calculation. It's about strategy.
Yeah, it's like having a roadmap and a compass instead of just wandering around aimlessly.
I like that analogy.
Yeah, it makes things a lot more efficient.
So you mentioned that they tested this MCTSR on a whole range of math problems.
Yeah, they really wanted to put it through the paces.
Right, from grade school level stuff.
Yep, starting with the basics.
All the way up to, like you said, those Olympiad-level problems.
Exactly. The kind of problems that would make even seasoned mathematicians sweat a little.
Yeah, I know. I would be sweating for sure.
But what's amazing is that MCTSR showed real promise across the board.
Okay, so give us some highlights. What were some of the most impressive results they saw?
Well, one of the standout data sets was math, which is based on high school math competitions.
Okay, so this is real deal stuff, not just textbook exercises.
Oh, yeah, this is where it gets competitive.
So how did MCTSR stack up against the competition, so to speak?
It consistently outperformed the LLMs alone, especially on those higher level problems.
So it's having that strategic element really gave it an edge.
Yeah, like a chess player who can think several moves ahead.
And then you mentioned Math Odyssey, right?
Right, that one was a real beast.
Yeah, I remember you saying those problems are uniquely challenging.
They are. They're designed to test deep conceptual understanding and problem-solving skills.
So how did MCTSR fare against the Math Odyssey titans?
It actually managed to crack almost 50% of those problems.
Wow, that's pretty impressive considering, we're talking about some of the toughest math problems out there.
It is, and it's a testament to the power of combining these different AI approaches.
So MCTSR might not be ready to publish groundbreaking mathematical proofs just yet,
Not quite.
but it's definitely a step in the right direction.
Absolutely, and it opens up all sorts of exciting possibilities for the future of AI and math.
Now, I know we talked about some of the limitations of this research last time.
Right, like the fact that they only tested it with one specific LLM, Llama 3.
Yeah, and that more research is needed to see how well this works with other LLMs.
Exactly. We need to see if this is a generalizable approach or if it's specific to Llama 3.
But even with those limitations, these results are still pretty encouraging.
Oh, yeah. They definitely give us a glimpse into what might be possible with AI and math in the years to come.
It's like AI is finally starting to tackle those problems that have stumped humans for centuries.
Yeah, it's pretty mind-blowing when you think about it.
And it's not just about, solving problems for the sake of solving them.
Right.
There are some really interesting practical applications here.
Absolutely, like in education, for example.
Yeah, imagine a world where every student has access to a personalized AI tutor.
That can adapt to their individual learning style and pace.
It could revolutionize the way we learn.
Yeah, it could make education more effective and accessible for everyone.
And it's not just limited to education, right?
No, not at all. This kind of technology could have a huge impact on fields like scientific research, engineering, finance, you name it.
It's like anywhere there's a complex problem that needs solving.
AI could potentially lend a hand.
I'm starting to see why people are so excited about the potential of AI.
Yeah, it's definitely a game changer.
But of course, with great power comes great responsibility.
Always.
So we need to make sure we're developing this technology ethically and responsibly.
Absolutely. We need to be mindful of the potential risks and biases and make sure AI is used for good.
So it's not just about the technical advancements, it's about the human element too.
Yeah, it's about making sure AI serves humanity, not the other way around.
And that's a conversation we need to be having right now.
Definitely, we need to be thinking about these issues from the very beginning.
So as we move forward with this research, what are some of the key questions we need to be asking?
Well, for one, how can we ensure that AI systems are fair and unbiased?
Right, because we don't want to just replicate existing inequalities.
Exactly. And how can we make sure that AI is used to benefit everyone, not just a select few?
These are some big questions.
They are, but they're important questions, and they're questions that we need to be grappling with as we develop this technology.
Because the future of AI is ultimately in our hands.
It is, and it's up to us to shape that future in a way that benefits all of humanity.
Well said. Okay, so
Yeah.
I think we've covered a lot of ground here.
We have.
We've talked about the technical details of MCT Azure, its potential applications, and the ethical considerations we need to keep in mind.
It's been a great discussion.
Yeah, absolutely. But before we wrap things up completely,
Right.
I wanted to touch on one more thing.
Okay, what's that?
We've been focusing a lot on like the nitty-gritty of how this AI works,
Right?
but I think it's also important to step back and appreciate the bigger picture.
I agree.
Like the fact that we're even having this conversation is pretty remarkable.
It is.
Like just a few years ago, the idea of AI solving complex math problems at this level.
It would have seemed like science fiction.
Yeah, exactly.
But now it's becoming a reality.
And it's just the beginning.
Yeah. Who knows what the future holds?
The possibilities are really endless.
They are. It's an exciting time to be alive.
Okay, so to wrap up part 2 of our deep dive,
Yep.
I just want to leave our listeners with this thought.
Okay.
The future of AI is full of potential, both good and bad.
All right.
And it's up to all of us to make sure that we're using this technology wisely and ethically.
Well said.
So stay tuned for part 3, where we'll wrap things up with some final thoughts and maybe even some predictions about what's to come.
Sounds good. All right, welcome back to our deep dive on AI and those really tough math problems.
Yeah, it's funny, we've been talking about all this really cutting-edge AI research.
Yeah.
But it makes you appreciate how far we've come.
Yeah.
Like even just a few years ago, this stuff would have seemed like, totally impossible.
Right, it's moving so fast.
Yeah, and speaking of which, I wanted to circle back to something we mentioned earlier about, how this new method, this MCTSR,
Yes.
compares to those like closed source AI systems.
Yeah, like GPT-4.
Yeah, exactly. Like GPT-4, those really powerful AIs that are kind of, shrouded in secrecy.
Yeah, the black boxes of AI.
And it really highlights one of the strengths of MCTSR, the fact that it's based on this open source Llama 3 model.
Absolutely. Yeah, that's a huge advantage.
Right. It's like with those closed source models, it's like you're trying to understand a magic trick, but you have no idea how the magician is actually doing it.
You just see the result.
Yeah, you just see the result. But with MCTSR, it's all out in the open, anyone can see how it works. They can tinker with it. They can contribute to its development.
Right. It's like democratizing access to these advanced AI capabilities.
Exactly. And what's amazing is that even with this, more accessible Llama 3 model, MCTSR is still able to hold its own against those closed source giants.
Yeah, it's pretty impressive.
Like it's achieving comparable results on many of those math problem sets.
Yeah, it shows you don't necessarily need a massive top secret AI to make significant progress.
Right. It's more about like cleverness and efficiency.
Exactly. Finding those elegant solutions.
So where does this all leave us? Like what does this mean for the future of AI and mathematics?
Well, it's definitely an exciting time to be working in this field.
Yeah?
I mean, just imagine, AI algorithms generating new theorems, proving complex conjectures, maybe even discovering entirely new branches of mathematics.
It's like having a mathematical muse whispering in your ear.
Yeah, I think we're still a ways off from that, but this research definitely points in that direction.
Yeah, and it raises some really interesting questions too.
Oh, absolutely.
Like, as AI becomes more and more powerful,
right.
What's the role of human mathematicians going to be?
Yeah, that's a big one.
And And how do we ensure that AI is used responsibly and ethically in this field?
Yeah, we have to think about the potential impact on society, on education,
Yeah.
on research.
And it's not just about math, right?
No, not at all. I mean, this kind of approach, this combination of LLMs and search algorithms,
Right.
it could be applied to all sorts of other fields.
Like what are some examples?
Well, think about, medicine, drug discovery, material science, engineering.
So it's really about like any field where there are complex problems that need to be solved.
Right, and where there's data that can be used to train these AI models.
Okay, so we're talking about a potential paradigm shift here.
Yeah, I think so.
Like AI is not just going to be a tool that helps us do things faster or more efficiently.
Right.
It's going to fundamentally change the way we approach these problems.
It's going to change the way we think.
Yeah.
And that's both exciting and a little bit daunting.
Yeah, I agree. There's a lot of potential here, but there's also a lot of responsibility.
Absolutely.
We need to make sure we're steering this technology in the right direction.
Yeah, and that's going to require a lot of careful thought and collaboration.
Well said.
Between researchers, policymakers, ethicists,
Yeah.
and the public.
Because ultimately, this technology is going to impact all of us.
It is. It's going to shape the future.
Okay, so as we wrap up this deep dive,
Yeah.
I just want to leave our listeners with one final thought.
Okay.
We've talked a lot about the technical aspects of this research,
Right.
and the potential implications, but at the end of the day, I think the most important thing is to remember that AI is a tool. And like any tool, it can be used for good or for bad.
It's up to us to decide how we use it.
Exactly. So let's use it wisely.
Let's use it to make the world a better place.
Absolutely. And let's keep exploring, keep asking questions, and keep pushing the boundaries of what's possible.
I couldn't agree more.
So thank you for joining us on this deep dive into the world of AI and mathematics.
It's been a pleasure.
We'll see you next time.